We learned how to find the concentration of solutions. And so today we're going to look at how do we dilute solutions. Do you know what that means when I say dilute something? Add more water, right? To water something down. So when I dilute something, does it become more concentrated or less concentrated? Less concentrated, right? I have more volume, but the same number of moles of my substance present, right? So my molarity decreases. So that's what we're looking at here. We're going to take a look at how can we make dilutions. Okay, typically to make a dilution, we start with something called a stock solution. And a stock solution is just a really concentrated version of the substance that we want. Typically, it's made in a manufacturing style lab, right? It's like a commercial thing, right? I order, for our lab experiments here, I order stock solutions that have a certain concentration. And I can just basically bank on that concentration being exactly what they say it is, right? Because it's really, really precisely made. Rather than me making a solution, taking the grams and putting it in and making a solution, that might not be super exact. And so I can order what we call stock solutions. And then if I want to water those down for our labs to be a little bit safer, I can do that. Okay, so I take these stock solutions and we find out how much stock solution we need to add and then water down the rest. So we use this equation for dilutions that says C1V1 equals C2V2. Any ideas or thoughts about what these variables might stand for? What do you Yep, this is volume. And we would measure that in liters. What do you think the C stands for? Concentration, right? And so that's going to be concentration. And it's probably measured in what? Molarity, right? So we see this equation helps us equate the initial and the final. So when we see 1, that's just like the before, and this is like the after, okay? So one side is the stock solution and one side is the dilution, right? How much needs to go in of the stock solution and how much of the dilution. So it's a pretty simple process and a pretty simple equation, but now let's go ahead and just put it to work. Let's practice some, okay? This one says we need 500 milliliters of a 1 molar acetic acid solution from a 17.4 molar stock solution. What volume of stock solution is required? We're really careful about what information goes together. We're typically going to be given 3 values, right? A volume, a concentration, or 2 concentrations, whatever we're going to be given. But we need to make sure we understand what goes together. Okay, I need 500 milliliters of a 1 molar solution. So those things go together, right? That's what I want to end up with. But I'm starting with 17.4 molar solution. Okay, so do you think I'm going to need a lot of that 17.4 molar solution or a little? Just probably a little, okay? But that's what I'm trying to solve for. So I'm going to set up my equation. C1V1 equals C2V2. Does it really matter the left or the right side of my equation, which I make the before and which I make the after? No. It does not matter. We just can't mix and match things, right? We have to make sure that one solution is on the same side one solution is together on the same side and the other solution's on the other side. So I'm just going to go ahead and put this here, 500 milliliters of a 1 molar solution. So concentration is 1 molar. My volume, it says 500 milliliters. So what's that going to be in liters? 0.5 liters. The concentration of my second solution is 17.4, and I'm solving for V2. Okay, so now it's just really simple algebra to get that worked out. Don't we agree? Okay, we're going to multiply on this side because parentheses is multiplication. So 1 times 0.5 is 0.5 equals 17.4 V2. So I will divide by 17.4 on both sides. So that means V2, 0.5 divided by 17.4. We get about 0.0287 liters. Is that similar to what you had? Okay, I want you to make sure you're running the math too. Don't just watch me run it in my calculator. I want you to go ahead and do it as well.
So it doesn't matter if I have like a 1 or 2 underneath the V?
Yeah, right. It doesn't matter if this says V1 or V2. It doesn't make a difference. Nope. Right? We're going to need that much volume of our stock solution. If I wanted to put that back into milliliters, what would that be? If I converted that back to milliliters, it would be what? 28.7 milliliters, right? It just asked for volume, so I would take your answer in either unit, okay? So this is what we're looking at. Our total goal was to have 500 milliliters of our solution. So we're saying out of that 500 milliliters, only 28.7 of it is the actual acid. The rest of it is just water, right? We're watering it down. So we were right when we said just a little of that, right? We needed 500 milliliters, but only 28.7 of it was actually our solution. Okay. Let me tell you one other thing. We did convert this to liters, which is good practice, but in all reality, as long as our volume is the same unit, as long as our volume is the same unit on both sides, right? That's a 2, sorry. As long as our volume unit is the same on both sides, we could have kept it in milliliters. Okay, so that's just something to think about. Because to convert, we're just multiplying by 1,000 or dividing by 1,000. So we're doing it the same on both sides. So if we're given a situation where we know both of our volumes and they're both in milliliters, they could stay. It would work out. All right, this one says, what concentration, so we're looking for the concentration of a stock solution do I need if 50 milliliters of stock solution is required to make 730 milliliters of a 0.83 molar solution. So there's a lot of things happening here, right? A lot of information happening. Can we figure out which things go together? Okay, what do I want to have? I want 730 milliliters of 0.83 molar solution. So those things have to go together, right? Because that's like my final. Okay, so I'll take, these are both in milliliters, aren't they? I'm just going to leave them in milliliters. So I'm going to take 730 milliliters times my concentration, 0.83 molar, equals, I want to know the concentration of my stock solution. So C2 would be my variable, right? I'm looking for C. The volume of my stock solution, it says it takes 50 mils for us to be able to get to our final goal. Okay, and so now I'm just looking for concentration. So 730 times 0.83 divided by 50. Did we get a concentration of about 12.1? 12.1 molar, right? That concentration does need to be in molarity, okay, big M. Also, in this chapter, it's really, really important that we specify, that's gross, okay, big M versus little m, right? Capital M for molarity needs to have mountains, right? Not hills, or however you describe that in your handwriting. But we need to make sure we're really clear that I can tell that's a capital M, right? Not a little m for something else. Okay? All right, let's try another one here. Why don't you try this one on your own? What volume of this sulfuric acid must be used to prepare this solution? So go ahead and try this one on your own. This says, what's the minimum volume of a 2 molar NaOH solution needed to make 150 milliliters of a 0.8 molar NaOH solution? Okay, what's the minimum volume? So I'm looking for V. I've got my concentration. That's what I'm aiming for. So again, here, are we expecting a lot or a little? A little, but more than last time, right? Our concentrations aren't so far apart this time. So we might have a more substantial amount of our stock solution. 2.0 molar times V1 equals 0.8 molar. You can keep it in milliliters if you want. Okay, is that what we had? What would be the unit in this case?
Milliliters.
It would be milliliters. Because I left this volume in milliliters, my answer here would have to be milliliters. Okay, if I had converted this 0.150 liters, then my answer would have come out 0.060 liters, right? You just have to make sure you're consistent on what unit you had on the other side. Okay. All right, any questions with that? That's where we're going to stop.